Hey everybody, we're going to go over the review here on this trig and right triangles chapter. So bear with me for a second here. Let me get the pen set up. Oops, that's where I want to be. Okay, so little Pythagorean theorem on this first page, problems 1, 3, and so forth. I might have the problems misnumbered here, or 1, 2, and 4, I think, Pythagorean theorem. So in this one, we have two sides. We don't know any angles, so that's kind of an indication to do Pythagorean theorem if you're trying to find a third side. So this 9 is the hypotenuse, what we call C. This would be maybe A, this would be B. But since we're looking for one of the legs, we have to do 9 squared minus 7 squared. And the math there is going to work out to be 81 minus 49, which you can let your calculator do all this. So you're going to do 32. And then you're going to take the square root of that to get side B. Square root of 32 is about 5.7. And you are done. Okay? Don't have to do any more on that problem. Just got to find the missing side with the Pythagorean theorem. This is our Pythagorean theorem. A squared plus B squared equals C squared, where C is the hypotenuse. So in this one, we'll call this ABC. Remember, we have a test here. If it's A squared plus B squared equals C squared, it's a right triangle. If A squared plus B squared is less than C squared, then that triangle is obtuse. And if A squared plus B squared is greater than C squared, then it's acute. So what do we got going here? We're going to have to do 11 squared plus 13 squared and test that against 17 squared. Well, the numbers play out like this. You get 290 over here, and you get 289 over here. And 290 is greater than 289, so you have yourself an acute triangle. All right? We don't know. We could do some work and actually do some inverse trig to find the angles, but they're not asking us to. So we're just asked to judge it. And we're going to judge it acute based on the numbers and based on the tests. All right. Those tests are up in the upper right corner if you're in class. They're also in your notes. They're also in your notes in the 7.2 section. All right, question 3. This one's a trig question because they give us an angle and some sides. It's a really skinny triangle. So the angle of depression, so we got the plane up here. We got the island here. The plane is 23,000 feet high. So that's this side, 23,000. That's hard. It doesn't look like 23,000, but that's what that is supposed to be. Let's see if I can make it skinnier, right, a little bit smaller. 23. There it is. We've got a right angle right there. That's the elevation of the plane. So the angle of depression is the same as somebody sitting on the island and looks up to see the plane, 8.5 degrees. That's this angle right here. So the 23,000, that's the opposite. This is adjacent leg, and this is the hypotenuse. And it says 20,000 height to distant ocean. How far is the island from the plane diagonally? So they want you to calculate the hypotenuse. So you're going to use sine. You say sin 8.5 is equal to 23,000 over x. Put it over 1, cross multiply. You get 23,000 is equal to x times sin 8.5. So you're going to divide by sin 8.5. So that little bit of math right here is going to kick out an answer. All right, so it's going to be about 155,606 feet. Let me just see. I had to check my answer here on a calculator quick. If you can't see me right now, I'm taking 23,000 divided by sin 8.5. Sin 8.5. All right. Yeah. Yep. So we could divide that by 5,280 and calculate how many miles the plane is away, but that's not what they're asking us to do right now. So a little bit of plane spotting. How far are you from the plane? 155,606 feet. That is this distance up here. All right, so this is kind of like a ladder wall question. How high will a 300 centimeter stick reach up the side of a wall if one end of the stick must be at least 30 centimeters from the base of the wall? So the stick itself is the hypotenuse. This is the wall. This is the distance away from the base of the wall. The wall and the stick make a 90 degree, or sorry, the wall and the base make a 90 degree angle. Stick is 300. This is 30. You're trying to calculate that. So this is a lot like problem number 1. We're going to have to do 300 squared. That's the hypotenuse minus 30 squared. And 300 minus 30 is, 300 squared minus 30 squared is 89,100. take the square root of that, and 298 centimeters up the wall. That's this distance right there. So another Pythagorean theorem. Two sides trying to find a third. Pythagorean theorem is your go-to. All right, next we flip over the page. A lot of stuff here. We could use some special triangles. We could do some trig on all this, and let's go. Okay, one thing you can do with this one is you could turn this 9 radical 3, 9 times the square root of 3 into a decimal. It's about 15.6. And we could do sine on this one. We could say sine 60 is equal to 15.6 over y. Y would be the hypotenuse. All right, 15.6 is the opposite. So 15.6 divided by y. And put it over 1, cross multiply. 15.6 is equal to y times sine 60 divided by sine 60. And that would take us there. Turns out your answer is going to be close to 18. All right, close to 18. Y is equal to 18. So that's number 5 on your sheet. The other way to do this one is to remember the shortcut triangle. This would be the long leg, LL. So you would divide it by the square root of 3 to get the short leg over here, which would be 9. And then 9 times 2 is 18. Because the hypotenuse is always twice the short leg. So, but you couldn't get trig. You don't have to remember the shortcuts if you just remember trig. All right, here, this is going to be a tangent one. Tan 39, because from 39 this is opposite and this is adjacent leg. Not doing anything with the hypotenuse. Tan 39 is equal to 14 over x. Make sure you set up your tangent as opposite over adjacent, TOA. All right, so we're going to cross multiply. This one's going to be divide one again. 14 is equal to x times tan 39. Divide by tan 39. All right, 14 divided by tan 39. When that gets all said and done, about 17.3. About 17.3. 14 divided by tan 39. Just checking. Yeah, 17.28. 17.3. There's that answer. Trigonometry. Next one's trigonometry again. From that 61, this one's going to be a sine one because this is opposite and this is a hypotenuse. So sine 61 is equal to x over 17. This one's a multiply one because you have your unknown in the top. 17 times sine 61 equals x. So when you get done with this one, 14.9. 14.9 for x. This one's a special one. You can do Pythagorean theorem on it, or if you ever see an isosceles right, a right triangle where the two legs are equal, you know these are both 45-degree angles. You could do the shortcut, and you could just say x times the square root of 2, so 7. That would be a fine answer. But if you want to do trig with it, or do Pythagorean theorem with it, that'd be okay. You could just do 7 squared plus 7 squared is equal to x squared. So this would be 98. Square root of 98 is 9.9. It's equal to x. Pythagorean theorem. You could also do this one with trig. You could say sin 45 is equal to 7 over x. And so you'd end up with 7 divided by sin 45. So there's more than one way to get this answer. This would work, this would work, this would work. You know, Pythagorean theorem, trig. Just got to find it. Just got to find it. All right, looking at number 9. A couple more here. This one's going to be cos, because this is the adjacent leg, and this is the hypotenuse. So cos 52 is equal to x over 15. Cross multiply it. X is equal to 15 times cos 52. All right, 15 times cos 52 is about 9.2. Nothing, there's no other way to do this one. There's no Pythagorean theorem here. There's no, there's nothing else to do. No Pythagorean theorem, no special right triangle. 10 you could do as a special, but you don't have to do it as a special. You could do sine or cosine. It all depends on which angle you want to use, which reference angle. If you tried just 30, you could do cos 30 is equal to 9 over y. You could also work with the 60 and do sine 60 equals 9 over y. But this would work. 9 is equal to y times cos 30, so we have to divide the 9 by cos 30. and that'll do it for you. There's other ways to do this one. You can use the shortcut, like 9 divided by the square root of 3 would take you to the short leg, and then the hypotenuse is 18 divided by the square root of 3, and that's okay. That's the one answer for the hypotenuse. That's the square root of 3 at the bottom there. But erase that and write it a little nicer. But doing this trig will get you the decimal answer, 18 divided by the square root of 3. The decimal answer is about 10.4. 10.4 is equal to y. Now this is equal to 10.4, but if you don't want to remember the shortcuts, use trig. Use trig. And the last one here, we could do Pythagorean theorem. We could use a shortcut because once you recognize these are the same, this is a lot like question 8. If you have two legs the same, you have 45-degree angles. So you could do trig. You could say cos 45 or sin 45, it doesn't matter, is equal to x over 12. It's really 12 divided by the square root of 2. That's one way to do the answer using the shortcut. But if you want to use trig, all right? The trig will work anywhere. So these are both 45 degrees angles. And so it'd be 12 times cos 45 to get x. And 12 times cos 45 is about 8.5. 8.5. Right? Yeah. 8.5 for x. Both of these are the same, so you don't have to do a second bit of work there. All right, and then the last one, the big suspension bridge question. So we're trying to figure out the full length across this bridge. So these two triangles here and here are the same. So let's do one of those triangles to we need this distance here. So we have the 140, that'd be the opposite. The x is the adjacent, so we're going to do tangent 19 is equal to 140 over x. So we're going to do a division here because we're going to have 140 divided by tangent 19. All right, when we do that bit of work, 140 divided by tangent 19, we get about 407. All right, about 407. So that means this distance is 407. Is this feet? No, meters. And this distance right here is 407 meters. Now the other triangles we have in play, let me switch colors on you here. The other triangles we have in play have this 10-degree angle with the 140, okay? The 10-degree angle with the 140. Now, those are going to work out to be tangent again, okay? We'll call this z down here, but we'll say tan 10 is equal to 140 over z. So we'll take 140 divided by tan 10 to get the z distances. The z distances are going to be 794. The picture doesn't do it justice. It looks like the 10s and the 19s should be switched, but when you get done with that, you get about 794. So this is a 794 distance, and this is 794 distance. So to finish this problem, you are going to take 407 plus 794 plus 407, or plus 794 plus another 407, because you got two of each. That, and that. And that's what you do. You add it all up, you get about 2,402 meters. So just a couple tangent problems with those estimates for the heights, and you have calculated the length across the span of the bridge. All right, that's it. All right, use some trigonometry. Do okay on the quiz, please, and that'll be awesome. All right, it's May 10th already. Holy cow.